this is my paper critique on the topic of Starling, which is a scalable query engine which is used to perform data analytics on cloud function services. So this is an overview diagram of how it works. So we'll dive into this. So let's discuss about what this paper is all about. So basically, Starling is kind of a fast service. So it is a function as a service in which you get a function. You don't have to worry about the infrastructure behind it. You can just input your codes and it'll give you the outputs. So we all know that having an on-prem solution is very expensive because you'll have to set up all the resources that you need to do that. So many people prefer cloud for this reason. And even with cloud, you will have cost issues because you will have instances wherein it will be running and you have to pay for it. And this is one such example of mine wherein I left few instances running and I had to pay nearly $2,000 for it. So no one likes paying extra money. So what would an ideal system be? An ideal system would be wherein you don't have to worry about all these things and you'll be only charged for the queries that you run and you don't have to worry about the performance also. So if you look at existing solutions, an AWS Lambda solution would come very close to this. And also, if you look at other cloud solutions, Google Cloud Functions and Azure Functions, they don't really come close to this because they have a lot of restrictions in terms of the language you can use or the speed or the rate at which you can implement it. So considering all this, why haven't we implemented such a thing? Because this could be revolutionary. So the key problems are we can't run these solutions for more than few minutes, and there's a lot of resource contention going on. You're resource constrained, and you'll have to do a lot of join operations in order to make sense. And these operations are very expensive, and it's kind of impractical considering the security policies that Amazon or other vendors set up. So we look at like three different parameters that the paper judges on. So they talk about the system does not require you to load data. So what does loading data mean is especially something like you have to change the format of the data to make sure that you can process it further. And the next parameter that they talk about is pay by query, wherein you're just paying for the queries you're running and not for the other things and tunable performance, as the name suggests. So it just gives you the option of tuning things. So what does what do we find in this paper? So we find that Starling as a solution effectively answers these 3 points, and it makes it a very viable option to data analytic workloads. And it does have its restrictions in the end. It is only good for low to moderate workloads. It's not like it can do very high workloads. And the only other competitor which is close by is Amazon's Athena. And what is the main contribution of the paper? The paper contributes by producing Starling, which itself is a revolutionary thing, which is a query processing function, which gives you data analytic outputs, and it overcomes all these three limitations, and it offers these as positive things, and it is easily very good in terms of performance, and it works on a large scale of data sets ranging from small to large. So what are the works this paper is based on? So this paper draws its inspiration from Amazon's Athena, and Athena is something which is exactly the same, but it doesn't address these three problems. And the author takes inspiration from three other components elsewhere, and he improves Athena as a whole. So he takes concepts from PyRun, which gives you parallel Python execution ability. So they use this in the form of C functions to do uh, uh, the queries, and they use GG functions. GG function has task management and handling of stragglers. So stragglers effectively means that slow functions, certain workloads will be slow and it can hold up the entire workflow. And all these things is effectively managed in GG. So we take that inspiration from there. And X camera is a parallel So they take parallelism idea from this thing. So how does this paper utilize these concepts? So yeah, so basically they have taken all these three different things and they have merged it together and they put it on Amazon, Amazon Athena framework, and they bring out a new product which like breaks through all the limitations that we saw earlier, and we'll see what it goes. So the only close thing that can come anywhere near this is AWS Lambda, and we managed to run Spark jobs on AWS Lambda, which comes close to this, but it is only restricted to Spark, nothing more. Okay, so let's see how they evaluated their data set. So they used two data sets. They used a 1 TB data set and a 10 TB data set, and this data set is especially used for performance related uh, evaluation. And they're also compressed. They use a format called Apache ORC, which is an optimized row column. So this this gives you very easy access of columns so that you can do multiple operations on it, and they use snappy compression to make the 1 TB data into 317 GB data. So they compare it against these six different platforms, and each one has its own pros and cons, and they're compared against operational cost, the performance cost, how it scales well, how it handles concurrent queries. We'll see all of these things. And before we go further, we need to see what optimizations we have made to match these six things that are here. Okay. So what improvements we have done is we have in the paper they have went and improve the parallel reading so that you can do multiple parallel operations together. But the one thing to note is after 16 parallel threads, it doesn't scale that much. There's no increase in throughput. And they handle the read stragglers. So anytime a function is waiting to read, what they do is they just open another function and they retry the same request and they keep whichever comes first as a result. And they do the similar for write straggler also, wherein they take up uh, the same concept as in read and they do it. And they also do something called as double write because S3 is kind of like stateless. What happens is sometimes an object won't come in the end till it completes. So what we do is we create two copies of it, and whichever is accessible, we use that and we kill the other one. And also we do pipelining. We do so for the shuffle operations, what we end up doing is if it is a small join operation, we do a direct shuffle. But if it is a very large shuffle operation, we use multiple stages of processes to do it. Okay. So if we use all these metrics to compete against the cloud vendors, and we'll see that when it comes to cost perspective, if you see here, uh, so this is the Starling's cost and this is the Redshift cost. You can clearly see that the graph is, I mean, the cost is very low and we see the same thing. And a key thing to note about these two graphs is that when it's low, Starling is really good, but when it increases, Starling also increases. But at the same time, its performance is also good. So if you look at the performance in terms of the latency that you see, it is good because it has low latency. And if you look at the cost that you spend on a query, you can again see that these costs by Starling is less. But do note that if there are a few theoretical predictions that if we use this, this could potentially be more powerful, that they do acknowledge these kind of things. And then there is support for concurrency, and they also talk about cost optimization and how Starling is very optimal and very powerful. And if you look at this, so this gives you all the, so if we saw that these are the improvements that we saw before. So we see the impact of each of those improvements. We add parallel rates, our latency comes down from 80 seconds to 20, and then it just keeps on going down as we add each and every component. And this is how it is. So when it comes to the critiques that I have, so the author did really well by setting up all the things because especially when it comes to these functions, what happens is sometimes they'll get rate limited and you will have issues with that and you will have to contact Amazon support again and again and again to get it done. So they've set up really well. They've taken different aspects and they've incorporated it very well. And they do acknowledge the pitfalls and other things that and the better offerings that Amazon offers. They handle Straggler migration very well, and they used a large data set to show that they can do really well. And they took a storage tool such as S3, considering all the latency it has compared to other solutions. They've taken such a thing and they use these aspects cleverly so that it can mitigate away its faults. And they use C++ as the source code for the query execution, which is good because C++ is really fast on hardware, and they do parallelism to save time. And it is all sets up groundwork for the big companies to take up and offer such services for us in the future. So things which I didn't find well is that they repeatedly say that it is the best. It is the best in a lot of places. But then when we look at it, there's a lot of fine tuning that happens to it compared to the other participants that it is put against. Under better configuration, the other participants may do really well. So because this is running at optimal, whereas the others are not, and they use a very dedicated format called as ORC to do it because it allows you to do indexes and other things on it. And when we take such a fine-tuned product, its impact on real world cannot be translated because we can have data sets which contains like CSV and all, and in real world it may not necessarily translate, and they don't use other different solutions in the backend such as SQS or DynamoDB. Maybe the performance could have been better. And when we handle very large shuffles, what tends to happen is because it spans up a lot more of work, so it'll end up becoming more expensive down the line than AWS offering. And if you're not planning it clearly, you will have to contact Amazon again and again and again to increase thresholds. And yeah, they do not leverage this offerings that Spectrum gives. Spectrum bypasses many of these faults, and they don't leverage it. So one thing, a few things that I could have done differently is I would have leveraged a better compression algorithm than Snappy, and I would see why the limit is at 16. I would try to increase it more, and I'll try to test out against different variety of workloads and see which will suit our product more and why it is so. And yeah, so as I stated before, they don't leverage the Redshift advantages, and Redshift on majority of the use cases comes out really good. It's slightly expensive, but it comes out really well. So if we can incorporate that into this, we can make it even better, and we can use the other alternate storage other than S3. So if there's anything that needs additional justification, I feel that those experiments that they did was very biased in a way, and I do get why they did that, but we should look at wide scenarios to make sure that we have a better view of the product and see what its actual true ground limitations are instead of giving it a very optimal use case and going from there. And what improvements I would suggest is change the underlying storage and see what happens, or change the kind of compute resources I'm providing it with and see what happens. All those things, basically the hardware, I just want to change it and see what it can happen. And basically, one more thing that I wanted to see is how will network get impacted? So if I have network latency, how will it impact in this? Or let's take something like what will happen, how my queries are affecting the answers, and how the data distribution is affecting answers. All those things can be followed up to make this even better. And some ideas I want to explore is that, yeah, again, I want to do all those variety of testing things, and I want to test its reliability against variety of situations. I want to check it against even more parameters that they checked it with before in the experiment. Starlight's potential is immense. It can do many things. So key thing is that it can be used in ML models, and when it comes to big data, a keyword is graph processing. So all those things are real world applications that this can be used in, and the existing cloud vendors can implement this, and they can provide a fine-tuned version of this so that everyone can access it. Thank you. So I've listed out all the references of the images that I've used from the paper. Thank you.